So in principle, we're going to look at discrete probabilities, okay? When you have a sample and you are taking something from the sample, okay? There are many different types of data in this world, many. But the way they are distributed is very important. You got to know the distribution of the data before you now work with the data, okay? So we need lots of different probability models to model the behavior of a certain type of data. For example, if you take the height of human beings, the height of human beings are normally they are not normally binomially distributed. They are normally distributed because many people have got similar height, between 5 and 7 thereabout. So height is normally distributed. When you are dealing with something that has a different distribution, you got to know the kind of probability model you are going to use. Take, for example, gender. Okay, gender. What kind of distribution do you think gender has? Type it there for me. What kind of distribution do you think gender, generally speaking, what kind of distribution do you think gender has? It's binomial, it's 2, okay? So one of the first distributions you're going to look at is the binomial distribution. Okay? So I'm going to give you the characteristics of the binomial distribution. And the binomial distribution is sometimes known as the Bernoulli trial. The Bernoulli trial. So let me give you some characteristics of the binomial distribution. I will later on compare the binomial distribution with a Poisson distribution. Okay. Don't worry, I'll explain all of this. And then we can now make some sense in them. So first thing, binomial distribution. I've given you an example. One of them is gender, male, female. It's generally binomial. But we'll come and look at a lot of examples very soon. The first characteristics of this Bernoulli trial or the binomial distribution is that there are 2 possible outcomes of each trial. Take that and keep it somewhere, write it down. There are 2 outcomes. 2, okay, the probability of the outcome is constant over time. So let's take, for example, if you throw a coin, into the air, there are only 2 possibilities that can come, a head or a tail. A head or a tail, okay? And the chances of a head happening is 50%. I'll come to this, okay? The chances of a head, because there are only 2 possibilities. So it means that the sample size is what? Is 2. If a head is coming, it is 1/2. If a tail is coming, it is 1/2. So the probability of a head is always going to be 1/2, 1/2, 1/2, and that is constant over time. That's what we're trying to say. Okay, the probabilities of that thing, that outcome happening is constant over time. 2. So first, there are 2 outcomes. Second, the likelihood of that outcome is constant. 3, the outcomes of the trials don't depend on each other. So it's not like a head depends on a tail, and a tail. No, they are not dependent. 4, the number of trials are distinct. Okay, they are integers. Okay, an integer, we've said it, an integer is a positive or negative whole number. But here we are talking about whole numbers. Okay? So the number of trials is a whole number. So how many times will you roll the thing? It's 1, it's 2, it's 3. It's not going to be 3.5, 1.5 times. No, the number of trials is discrete. Okay. So let's now understand what the distribution is. So if I roll the head, whatever, if I roll the coin and I roll it again, and I roll it again, and I roll it again, by rolling it multiple times, I'm able to detect the way it is distributed. I'm able to see the distribution. My Italian friend will say a distribution of the whole thing. Now, the probability of a success happening is P. We said it before. And the probability of a failure or not a success happening is 1 minus P. Remember, guys, probability is always between 0 and what? And 1. So if a coin is tossed many times, we've said that the outcomes are just 2, head or tail. And that is why it's binomial. Okay? It's not the same as when you roll a dice. When you roll a dice, check it carefully, the outcomes are not 2. There are 6 possible outcomes, so it's become multinomial. So the distribution is not binomial for a dice, is multinomial. But the distribution for rolling a coin is binomial. The distribution of gender is binomial. There are several other examples that I'm going to be asking pretty soon to tell me whether they are binomial or they are not binomial. Okay. Now, so let's get some examples. So the first example of a Bernoulli trial is head or tail of a coin, or the toss of a coin. That is the first one, coin toss. Who can tell me another possibility? Don't mention the gender that I spoke about. Look, tell me another thing that has a possibility of 2 possible outcomes. Anything that can be 2 possible, that can have 2 possible outcomes. Who can give me one example? Michael, you have one example. Tell them.
Death or being alive.
Good. Death or life. Okay. So what he's talking about is life or death. Fantastic. It is clear. What else? What else? What are other examples? Look, you have to be saying some. Okay. Reginald, say some.
Yes, Doc. So can we say a penalty kick?
No.
In
See,
football.
The fact that you couldn't even tell me the other option shows that you didn't think it deep. So think about another option. Emmanuel.
Okay, so doctor, married or single?
Married or single, no, because you can have in between, widow, divorced, and all of that.
Okay.
You're thinking too much. You're free.
Pass or fail.
Pass or fail, fantastic. Okay, you can have that. Pass or fail is a typical example of that. Now, Charity, other of you. Pass or fail.
Win or lose.
Win or lose, very good. Win or lose, okay? Win or lose is another example. Suppose you have to give 10. That's what you want to do now, okay? If suppose you have to give 10 examples, that is all you have to do now, because your capability to give examples now will help you give 10 examples when you're pushed to the wall, okay? What other examples can you think about that as a Bernoulli trial? Any other person with another example? Let's go to Efia. Efia and Agnes.
Light or darkness?
Light or darkness? There is no in between.
Oh.
Okay. Light or darkness? Adrena. Agnes.
Yes, doctor, I wanted to comment on the win or the loss. What of a draw?
Well, it depends on where you are looking at it. Okay. So I understand. That came into my mind. It depends on where you are looking at it. What if there's no draw?
Okay.
You know, those kind of things where you have to win or lose.
Okay. Thank you.
Edwina, Agnes.
Yes, sir, please open or close.
Open or close, okay? Don't let anybody come and think of possibilities of half open and half closed. But at least you get a point, okay? You get a point. So some of the examples that are normally used in the probability literature are defective and not defective light bulbs, okay? Okay, contract. Either you win the contract or you lose the contract. Responses, whether you get a yes or you get a no. Application, whether you are accepted or you are rejected. So all of these are examples of a Bernoulli trial. Okay. Now, I'm going to give you the binomial formula because that is what we are going to use. And you have to understand the binomial formula because that is what we use to compute a Bernoulli trial. And then we'll look at a couple of examples. But before we look at that example, I will compare the binomial distribution with a Poisson distribution so that you can get a better understanding of all that we are discussing here. Okay, so write this formula as I'm writing. I've written it many times, but I'm writing it again because I want you to learn how to write it. Then I will explain what it means. The probability formula is given as P into bracket X equal to, write it. There's a reason why you write it, because you write it, it sticks in your mind. Okay? P into bracket X, then you have n factorial divided by x factorial into bracket n minus x all factorial. Then you'll be multiplying that by the probability of x, and then 1 minus the probability. Okay, probability of x, and then 1 minus the probability n minus x. This is a binomial formula. I'm going to explain the content of it, and then you'll understand. So first of all, I mentioned something, the exclamation mark like. Okay, that thing is called factorial. Factorial. It is on your calculator. It's on your calculator. So that's the name for it, factorial. But let's try to get something. Those of you who have factorial, find 0 factorial, and let me tell you something. Find 0 factorial. Now, for some of you, you have to press your shift key before you actually get it. Okay? So what is 0 factorial? 0 factorial is always equal to is 1. Keep that in mind. That is the easier one I want to tell you. Okay, find 0 factorial, and that is equal to 1. Okay, now find 1 factorial. 1 factorial. What is 1 factorial? That is also what? 1. Okay, now listen. What is 2 factorial? I'm helping you quickly. What is 2 factorial? So a factorial is defined as the number multiplied by the next number below it, the next integer below it. So 2 factorial will be 2 times 1. 3 factorial will be 3 times 2 times 1. 4 factorial will be 4 times 3 times 2 times 1. I'm sure you get it now. Now, what is 6 factorial? What is 6 factorial? Type the answer there, let me see. Type the answer for 6 factorial for me. What is 6 factorial? This means that you must have your calculator in front of you. 720. Okay, now you get it. Now you get it. That's what we mean by factorial. So I've defined that first. Now let's go to the next thing in the formula. Okay, the next is I'm defining quite a bit of the easier ones. Okay, the next one is P. P, and obviously that will give you a clue that P is the probability of success. Okay, so I'll come back to explain that. P is the probability of success. So if I throw a coin and I get a head appearing, its probability is the probability of success. So guys, if I throw a coin and I get a head, the chances of me getting the head is what? And when I say the chances of me getting the head, I'm talking about the probability of success. The chances of me getting the head is what? It's 0.5. Okay, it's half. And so the probability of success is what? It's 0.5. The chances of me not getting ahead is what? Is 1 minus the probability of the chances of me getting ahead. So it will be 1 minus the 0.5. That is what we call 1 minus the P. So the probability of success is the P. And 1 minus the probability of success is the probability of failure. Okay, so that's why you know that. If you don't get it, you raise your hand. The next thing in the formula is N. Who can tell me what N is? Who can guess what N is? Because your capability of guessing shows that you have some idea. Okay, so Agnes, tell me, what does the N stand for?
Exactly the sample size.
The sample size. So in this context of what we are discussing, what would be the, in terms of the coin toss and all of that, what give me an example of what could be the sample size. Explain what could be the sample size.
Okay, so for the coin toss, the sample size will be 2, since we have 2 faces of the coin.
Okay, I knew this is what you might say, but that is not really the sample size in that coin toss thing. That is not really the sample size in the coin toss. So in the coin toss, what would be the sample size here? Redeemer.
The number of times the coin was tossed.
That is the point. So the coin toss, that if I throw it, boom, and I throw it again, boom, and I throw it again, boom. That is 3 times. So that is the sample size. So the sample size is the number of times the action was taken. The number of times the action was taken. Please, guys, note this, because we are getting deeper and deeper. The last thing in the formula is the X. What is the X? I'll explain it, because you see, it's not just memorizing it, but understanding it. If I throw that coin multiple times, let's say 3 times that I gave, the chances of me getting ahead, if it's ahead, and let's say I'm looking for a head, I'm praying that I'll get ahead. Okay, if head is my prayer, then head is my success. So the X is the number of successes. Okay, but guys, get something clear. The number of successes is the X, which means that you can have the number of failures. So let's say that I want head. I'm throwing the thing 3 times. I want head to appear twice. I want head to appear twice. So my number of successes here is 2. My number of failures is 1. Okay, so the number of success, the number, not the probability of success. X is the number of success. And usually that is what you are going to be always asked to find. You are going to be asked to find that number of success in a certain way, either maybe more of that, less of that, exactly of that, no less than that, and all of that. Okay? Don't look at the example, but just know that X is the number of successes. Example is more efficacious than precept. So I'll be giving you some examples very soon. Okay, the next thing, and before I give you the examples, I'm going to that next thing. The next thing about probability is to know the, what we call the descriptive statistics. See, any distribution in this world, you got to know two aspects of it. Okay, when you have a distribution, you should be able to know the mean, the central tendency, and then the dispersion, the variability or the variance of that. So we need to know what is the mean and the variance of the binomial distribution. What is the mean and the variance of the binomial distribution? Ladies and gentlemen, the mean and the variance of the binomial distribution can be summarized by these 2 formulas. Watch it. Let's go to the mean first, the bottom one. The mean is also called expected value of the success, the number of success. So the expected value of the item, and please note, anytime you hear the word expected value, is also the mean. The expected value is 1, the item, okay, the number of success, multiplied by its probability. The number of success multiplied by its probability. So let's say that the number of successes are 4, 10, 20. Okay. And each one of them has got its probability. 4 has gotten a probability of 0.4. 10 has got a probability of 0.1. And then 12 has got a probability of 0.5. What you are going to do, you are going to multiply each occurrence by its probability, each occurrence by its probability, each occurrence by its probability, and then you sum them. So it is 4 times 0.4, 10 times 0.1, 12 times 0.5, and then you add them, and that is the expected value, or that's the mean. So the way you normally find the mean in real life situation, how do you find the mean? If I tell you that I have 2, 4, and then 5, and I tell you to find the mean, what do? You add them, and then you divide it by what? By 3. That's how you find the mean. Okay. But here, the mean, which is expected value of a binomial distribution, is that item, okay, multiplied by its probability, okay, the probability of the item. Okay, so keep that in mind. The variance, and remember, you always want to know the mean and the variance, Okay. So what is the variance? The variance is given by the sigma square here. The variance is given by the sigma square. Watch how it is calculated. It is the item, the number of occurrence, the success, minus the expected value. The expected value is the mean. So it's like you subtract the mean from each of the occurrences, you square that, multiplied by the probability, and then you sum all of them. Okay. So you get a probability of each one, the mean subtracted from each of the items, squared, and then whatever square you have, multiplied by the probability, and then you sum them. This formula is what you have. So just keep the mean and then the variance in mind. Don't memorize it, just keep it in mind. And the one way to keep it in mind is to write it down. Okay, let's go to Poisson distribution. What is the difference between a binomial distribution and a Poisson distribution? Pay attention, this is where it gets deeper. And I want you to underline some key things. Binomial distribution, one of the key things you know is that you are talking about two things, okay? Two outcomes, okay? All right, so somebody's hand is up. Charity. Charity, ask a question.
Sir, please, I didn't quite get the explanation very well about the mean before we move to this one.
Okay, the possible reason why you didn't get it very well is because I've not given you an example. So when I give you an example, you get it. It's just a formula, and you're going to substitute some things into the formula. So when I give you two examples, you get it. Don't worry, because now it looks abstract.
Okay, sir.
All right. Now, let's go to Poisson. I'm going to give you more examples of each one. Poisson, and we call it a distribution. So, guys, what it means that certain things are binomially distributed. We've looked at examples very soon. But certain things are also not binomially distributed, mate. There are certain things you don't even know. Remember, these are not the only distribution. There is a normal distribution. There is a Weibull distribution. Okay. We have several other distributions, okay, that we know in the literature. Okay, different. You have half normal, truncated normal, Leontief, log normal, and several things. Okay. There are several distributions in the world. What is a Poisson distribution? The Poisson distribution, and take note of this and write it down, focuses on a given continuous time interval. In other words, the number of successes, remember, in binomial, there is a number of successes which is exact. In Poisson, the number of successes is a continuous thing. So the number of successes is an average. It is not an exact value. And again, this might look a bit abstract. So the distribution, okay, focuses on the average of the thing happening. And the thing can, the number of successes can happen an average of a time, an average of a space, an average of a length. And I'll give you an example. Let's talk about the number of arrivals in a shop in 1 hour. The number of arrivals in a bank within an hour. So first thing you will notice that there is a time that is limited given. There is 1 hour which has been given. So that 1 hour is the limitation. So the thing has a limitation. That is a time limitation in this case. And now you are counting how many people arrived in the bank within that 1 hour. How many people are arriving in the bank? So let's say 15 people arrive in the bank within that 1 hour. That number 15 is the average. That number 15 is the average. So you see 15 people. Okay? But this thing must have been studied over time. Maybe historically, we've known that every Monday, 15 people on average arrive within an hour. So there's a limitation within an hour. Look at if I tell you that the number of goals scored in a football match, the number of goals scored in a football match, do you realize that there is a certain time limit there already, even though I have not mentioned it? What time limit is that? What time limit? The number of goals scored in a football match. What time limit is there? Okay. Fantastic. Okay. The time limit is 90 minutes. You know it. Okay. So even though this particular one wasn't mentioned, you know it. So if I tell you that the arrival at a bank cash machine, I must have given you a time limit for you to get it. Now, let's get deeper. Let's get deeper. The difference between the binomial and then the Poisson. And I'm telling you this difference because this is what sometimes you need to be able to crack each one of them. The difference between binomial and Poisson. The first difference is this. Binomial is giving you a fixed number of trials. That's what binomial is giving you, a fixed number of trials. So that sample size is fixed. But then the Poisson gives you innumerable, a lot of uncountable number of trials. There are several possibilities of that happening. That's the first thing. Now that first thing might even be a bit abstract for some. So let's get deeper. Binomial, there are only 2 possible outcomes. Poisson, there are a lot of outcomes. Binomial, only 2 possible outcomes is either you reject or you accept. Only 2 possible outcomes. But normal, Poisson, there are more than 2. The probability of success in binomial, we said it. The probability of success, like a head or a tail, is constant. But in a binomial, in a Poisson, the average is what is constant. The average is not the probability of the success, but the average of the success. The average of the success. Now, the best way to get the main difference between the two is this. Exact probability is given in a binomial. Exact probability is given in a binomial. But the average probability is given in a Poisson. The average, when I say average, average over time, over space, over, a page, over a mile, over a second. So that thing is limited. The average over that time, time is unlimited. I will give you a limitation of that time. The average of a space, the world is spacious, it's unlimited. I'll give you a certain space. Okay? So I can tell you how many runnings can you do within that space that has been given to you. So take note of the 2. Mean or average is for Poisson. Exact probability is for binomial. Let's get an example. Okay. I'm going to ask you some questions here. And the questions I'm about to ask you, yours is to just tell me whether the statement I'm about to make is a Poisson distributional statement or is a binomial distributional statement. Let's take the first one. The number of imperfections per square meter of a glass panel used to make LCD televisions. Raise your hand and tell me. The number of imperfections per square meter of a glass panel used to make LCD televisions. Is it a binomial or a Poisson? You can tell me. Is it a binomial or a Poisson? Looking at the little knowledge you have so far, is it a binomial or a Poisson? You can tell me. Somebody's thinking. Somebody's thinking like it's never told before. Is it a binomial or a Poisson? Okay, Daniel, is it a binomial or a Poisson? Yeah.
Hello. Hello.
Yeah.
Yeah, it's a binomial.
It's binomial. What makes you say it's binomial?
There are only two possible outcomes. Either it is perfect or imperfect.
Okay. So unfortunately, that is not correct, because you can see that the moment you have per square meter, a certain space is given. It's limited per square meter. Okay. So you can see that the per square meter is telling you that there is a limitation. So that average. So yes, imperfection, but within a certain a particular per square meter. And so this is a Poisson distributional statement. Okay, let's go to the next one. And again, the intention is to make you think, so you get some of them wrong. Okay. The next one, the number of robot malfunctions per day on assembly line. The number of robot malfunctions per day on an assembly line. I think this one you get it. Is it binomial or Poisson? Michael, is it binomial or Poisson?
It's Poisson. Is it because of the per day?
Perfect. That's it. Okay, you're getting it now. Gradually, we are getting there. Next one. The number of telephone calls arriving at the help desk of a software company during a 10-minute period. Is it binomial or Poisson? Is it binomial or Poisson?
So this is Poisson.
It is Poisson. So all of these things are Poisson, actually. Okay. But of course, the first one, sometimes, who really got the first one correct? Okay. If you got that first one correct, it means that you have been following us. Okay, now let's go back to the Poisson. Let's get the mean and then the variance. Do you remember that we did the same thing for the binomial? You got to know the mean and then the variance. Now, what is the mean? What is the variance? First, let's get the Poisson formula. The Poisson formula is P into bracket X, e raised to the power -1, okay, lambda. Okay, that thing is a lambda, -1, e raised to the power negative lambda, and then lambda raised to the power X, all divided by X factorial. Please don't be worried about this strange formula, because this is a master's degree, okay? And even undergrad, they do these things. So what is the PX? We've said it before. The PX is always a probability of success. But in the case of the Poisson, listen, in the case of the Poisson, is the probability of success over time, over space, over per square meter, over per mile or something. So note that in the case of this, it is over a certain time period or over a certain space period. Now, that is the first one. That is the X. The lambda is the mean. The lambda is the mean, is the average. So it's the average of the success. It's the average of, and you will always be told what that average of the success is if you listen to it. The X, and by the way, the probability of the X is what you will be asked to find. The X is the number of successes, just like the binomial. The only thing is that in this case is the number of successes within that interval, And the E is a natural log, okay? Is a natural log that we know. If you look at your calculator and you type the natural log of, E, you will see that it is 2.718, 2.71. This is a standard natural log in calculating mathematics. Okay, so that is a Poisson formula. Okay. Write it down. If you haven't written it down all this while I'm talking, write it down. That is the Poisson formula. Write it down. That is a Poisson formula. Now, what is the mean and what is the variance? Just like the binomial, what is the mean and what is the variance of the Poisson? Well, it's interesting. The mean is the mean. The mean, which is expected value of X, is the lambda, which is the mean. Remember, we explained the lambda in the previous section as the mean, the average. And then the variance is also that same average. So in Poisson, the mean, you see, certain things are Poisson distributed in this world. Okay, and you see that. okay, as we get to Q-in models. So I just know that the mean and the standard deviation are the same for Poisson. Ladies and gentlemen, we are now ready to look at examples. So what I'm going to do with you now is to look at multiple examples so that you can get it. I told you examples are more efficacious than precept. So in the next 1 hour, we're going to be digging a lot into different examples. The main thing for you to do with me now is to have your pen and paper and book ready as I show you this. Your job in every question I'm going to work with you is to identify first whether it's a Poisson question or is a binomial question. Is a Poisson or is a binomial? Let's take the first one. What is the probability of one success in 5 observations if the probability of success is 0.1? What is the probability of one success in 5 observations if the probability of success is 0.1? Who can raise a hand and tell me whether this is binomial or is a Poisson question? And what gave you the clue? What gave you the clue? Michael, is it binomial or Poisson? Is it binomial?
It's binomial.
Are you sure?
Yes, so.
Pretty, is it yes, so?
Yes.
Okay. What makes you think so? Michael, what makes you think so? Because I cannot let you go like that.
Okay, so the reason is there is no average inside, and it is exact. Like it's for 5 observations, so that they are given at a specific number, but we are not finding the average of the observation, but rather the 5 observations.
Okay. Another person's hand was up. All right, so this is binomial. He's right. Okay. First of all, the probability of success has been given. That is one thing you can see there. Second, you are being asked to find the probability of one success. Okay, not one success in 3 different time period or something. Okay? No average time period or space period has been given. And so that is a binomial. Once you get to know that is binomial, okay, guys, your first thing you got to do is to identify the elements of the binomial. What are the elements of the binomial? You have to identify the p, you put it down. You have to identify the 1 minus the p, you put it down. You have to identify the n, you put it down. You have to identify the x, you put it down. So if it is a binomial, you need to know all of this. And regarding the x, sometimes there will be a little bit of tweak in the x. I'll come back to that. Okay. So what is a p? What is a probability of success in this question? What is the probability of success? What is a p? What is a value? What is a p? Raise your hand or type it for me and let me see. What is a p? This one is so easy than ever before. Yes, Nanabing.
So this is 0.1.
And what is a 1 minus a p?
That will be 1 minus 0.1, which will give you 0.9.
Good. So the p is 0.1, and this is 0.9. What is the n? The sample size. What is the n? The sample size. Can you type that for me? The n, the sample size. Type it for me. Agnes says 5. Elena says 5. Okay. Hannah says 5. Emmanuel says 5. Okay. So the n is 5. What is the x? What is the value of the x in this very question? Okay. The x. Okay. Remember, x is the number of success. And in this context, it was given. S is what? Is 1. Okay. It says 1 success. 1 success. So x is 1. So knowing all of these elements, What you got to do now is to put it into the binomial formula. You've written the formula already. So I want you to substitute this into the binomial formula now. Find me the value, okay, the probability of one success in 5 observations if the probability of success is 0.1. What did you get? Substitute it, use your calculator. See, this is a hands-on work. If you don't do some, if you don't punch it and do it and actually commandeer, because your calculator can fail you depending on the way you punch it. So you got to be in the exercising mode, the actionable mode, as far as this is concerned. When you are done, raise your hand and tell me how you worked it. Okay? And please, if you use your calculator, if you punched it with your fingers, let me know. Okay. If you punched it with your fingers, then you raise your hand and tell me the answer. Raise your hand and then communicate your answer for me. Michael, are you done? Because your hand is up. Are you done, Michael? When your hand is up, what it means is that you are done. Michael, I've allowed you to unmute yourself and tell me whether your hand is up or not. So take your time and work this thing for me in 1 minute. All right. I say raise your hand and walk me through how you did it. Because I wouldn't know whether you picked the answer from somewhere or somebody gave you the answer. Okay. I want to be sure you punch the calculator. Teresa. Okay, so Teresa, mute yourself and then tell me.
Okay, yes, so the formula was so n factorial, that would be 5 factorial divided by 1 factorial into brackets 5 minus 1.
Did you use your calculator?
Yes, please.
All right.
So then you get 120 over 1. Then into brackets will be 4, all factorial. So that would be 120 over 24. Then you get 5. 120 divided by 24 would give you 5.
And so your final answer is what? 5.
Yes, sir.
And that was wrong. That was beautifully wrong. And it's okay because you got to get it wrong here than then. So we are going to look at how you get that wrong. What happened? Let me go to, because that's why I want you to do it. Because if you don't do it, your mind will tell you that you are good. That's what your mind tells you. The mind is telling you right now, I'm good, I can do it. Oh, without a calculator. Once I get a calculator, I can do it. You get a calculator, you can do it. Daniel, tell us. Unmute yourself, Daniel, and tell me how you get it.
It's going to be 5 factorial over 1 factorial into bracket 5 minus 1 factorial.
Which is 4 factorial.
0.1 raised to the power. Yes. Times 0.1 raised to the power 1 times 1 minus 0.1 raised to the power 4.
So what did you get?
Yes. I've not arrived at the final answer, but that is how
then you shouldn't get that whole thing. Punch it on the calculator. Be sure what you are doing before you actually said, I've not arrived. I want those who have finished it to talk, not those who have not finished. So Daniel, take your time, get the thing worked out before. Let me go to Redeemer. Okay. Redeemer, Tell them how you went around it.
Okay, so the 5 factorial over 4 factorial.
What was your answer?
0.325.
0.325. That is the right answer. Okay, so now go ahead.
So the 5 factorial over the 4 factorial times 0.1 into bracket 0.9 raised to the power 5 minus 1. Then all that comes to 120 over 24 times 0.06, which gives me the 5 times 0.065, which gives me 0.325. Good.
Now, the reason why I take that is because there are a bit of decimal changes and all of that. So that is approximately 32%, 0.325, 32%, or better, so 33%. So that is your closest answer in this guy. Guys, you got to know, let me tell you some mistakes some will do. Many people will go and solve this. You got to solve the ones with the powers first. Solve those ones first. Okay. 1 minus the 0.1 factorial is 0.9. So you take a calculator, you do 0.9 raised to the power 4. Now, some people don't even know where the raised to the power 4 is on the calculator. If you don't know that, you miss that. If you don't know that, you miss that. Some people would not know that you have to press some shift key before you press some factorials. Some people would not know that you have to press some shift key before you press some exponent. Again, you got to be familiar. The calculator got to be your friend. You got to get this thing done. Now, for those of you who have gotten it wrong, go over it again and again and make sure that this is done. This is key. This is key. You have that whole thing in your mind, but you get it wrong. That's a side. And that is because you and the calculator are not friendly. Know which portion of the calculator to punch together. Let's go to the next one. Let's go to the next one. The next question. What is the probability of getting exactly 2 tails in 3 tosses of a coin? What is the probability of getting exactly 2 tails in 3 tosses of a coin? Is this binomial or Poisson? I'm going to work this with you. As I thought the first one, most of you will get it, but now I need to work a lot too. Okay. Let me go back to the question before you don't. Is this binomial or Poisson? What is the probability of getting exactly 2 tails in 3 tosses of a coin? 2 tails in 3 tosses of a coin. Is this binomial or it is Poisson? Is this binomial or it's Poisson? Teresa, is this binomial or Poisson? Unmute yourself and tell.
This is binomial.
Why?
Because we are given the number of tosses of the coin, which is 3. That's exact.
Well, that is not why. That is not why. I like your answer, but your reason is not why. You got to get these things right. Why? Why? Nana Benin, do you have the idea? Why is this a binomial?
Yes, sir, because it's a coin toss, and a coin toss, you only have 2 possible outcomes of each trial.
That is it. In this case, it's a coin toss. Okay, there's a coin toss, and in this context, that is an exact, coin toss. And there's something in here that you have to also note, and it has to do with the probability. Okay, it says what is the probability of getting exactly? So there is a probability in the coin toss. We know that in our head, and that probability in a coin toss is either a head being 50%, or it's got to know that. And that is what, so the probability is exact. There is no average in there. And it is a coin toss. And the coin toss is the commonest example I've been using all these while, isn't it? Okay, as a binomial. Okay, so now we know that is binomial. You see, your most important thing is to note what it is, whether it's a binomial or Poisson. That's why I'm mixing the 2 questions. All right. Once you've identified that it's binomial, you've got to know the P, you got to know the 1 minus the P, you got to know the N, you got to know the X. Okay. So let's try to find from the question, okay, which is which. Let's try to find out which is which. Because again, your capacity to identify this is important. So let's go back to the question. What is the probability of getting exactly 2 tails in 3 tosses of a coin? 2 tails, exactly 2 tails in 3 tosses of a coin. So on the basis of what is the P? What is the probability of success? What is the P? What is the probability of success? Remember, this is a binomial, and this is a coin toss. What is the P? What is the probability of success? And what is the probability of failure, or the 1 minus the P? A coin toss. Okay, somebody has typed 2. First of all, probability can never be 2. The probability can never be 2. Remember, probability is always between 0 and 1. So I'm asking, what is the probability of success? Remember the binomial formula. Look at it, look at it, look at it with your eye. Some of you are thinking, some of you are about to. Okay. What is it? We know from the onset that anytime you toss a coin, there are only 2 possibilities, a head or a tail. And the probability of success is a head, or a probability of failure is a tail, or a probability of success is a tail. Okay? So the chances of a tail happening is 50%. We know that. So this one, the question didn't tell you the probability, but you got to know that in the toss of a coin, it is always 50% for head, 50% for tail. You get a point. You get a point. So you got to know some of these things so the probability of success is, in this case, the probability of we having a tail. Okay, and this is what, 0.5. Okay, 50%. And the probability of failure is we having a head. Okay. Whether you bring we having a head or we having a tail doesn't matter. What is key is that knowing that each of them will be 50%. That's it. Now let's go to the sample size. The sample size. Okay, so in this question, what is a sample size? What is a sample size? What is the N? What is the sample size? What is the N? See, now some of you are getting the picture. The sample size is the 3 tosses. The 3 tosses. So there's a toss, but this time there were 3 times. Okay, so and then let's get the X. Let's get the X. The X is what? So remember, the sample size is 3. Keep that in mind. What about the X? The X value is what? Okay, remember that X is the number of success, and in this case, it is the 2 tails. So the X is 2. Okay, the X is 2. So watch something. But they use a certain way. So this sample size is 3, but the X, they said exactly 2. And I want to emphasize on the word exactly. Because if he had said more than 2, it would be different. So guys, what is exactly 2? Exactly 2 is equal to 2. Finish. Exactly 2 is 2. So once you get that, you got to write your probability formula. The probability formula is P into brackets X equal to 2. So you put X equal to 2 in the bracket there. Okay. You put X equal to 2 in the bracket because we are talking about exactly 2. Okay. So you now have a probability of X equal to 2, okay, which is what you are looking for. You're not looking for anything different from X equal to 2. And it's always nice to write a formula. It's n factorial, okay, divided by x factorial into bracket n minus x all factorial, okay, multiplied by the probability of x, multiplied by the probability of 1 minus x to the power n minus x, 1 minus p to the power n minus x. So you got to know this thing. And then you start substituting. I'm working this with you. Remember, we are looking at the probability that x is exactly 2. Okay. N factorial is 3 factorial. The first thing is to substitute. 2 factorial is the x factorial. Okay. N minus x is a 3 minus 2. And that is what? 3 minus 2 is 1. So you have 1 factorial. The probability of x is 0.5. So you have 0.5 to the power x. X is what? 2. And then you have 1 minus p. 1 minus p is also 0.5. So that one, 2.5 to the power n minus x. N minus x is already 2. We found that to be 2. It is 3 minus. Sorry, n minus x is 1. So we find that to be 3 minus 2, which is 1. So you are talking about 0.5 raised to the power 2, and then 0.5 raised to the power 1. Okay. And then that will be multiplying 3 factorial. So your calculator must be beautiful. 3 factorial is 3 times 2 times 1, and that is 6. Okay. 2 factorial is 2 times 1. 1 factorial is 1. Okay. So 2 factorial is 2. 2 times 1, which is 2. Okay. And then you multiply 2 by 1. That gives you 2. So you have 6 over 2 here. Charity, your hand is up. So this is where your calculator must be with you. This is not something that somebody has to work with you. Charity, unmute yourself and ask a question.
Sir.
Yeah.
Please, about the 5 points and 0.5 raised to the power 2. Is it because x is exactly 2?
Yes.
Because I'm not. Okay.
Yes, that is because x, because that value is x. If you look at it here, it is x. So it is p raised to the power x. It is in the formula. It's all in the formula. So that's what we are just doing. We are just substituting it into the formula. And then the other one is n minus x. So that will be 3 minus 2, which is 1. Okay.
Thank you.
All right. So once you do that nicely, if you check the value of this, 0.5 to the power 2 will give you 0.25. Check your calculator. It's like 0.5 times 0.5. That's what it is. And then 0.5 to the power 1, that one window is going to be 0.5. Now 6 divided by 2 is 3. Okay. So you now multiply that 3 times a 0.25 times a 0.5. What did you get? I know the answer here, but let me see whether somebody truly worked it. What did you get? Those of you who worked, what did you get? See, if you have worked, okay, it's good you are moving along with me. Your pen must be shaking on your paper, dancing on your paper. Fantastic answers. I'm getting 0.375. Okay? 0.375. And that is the exact answer that you, if you worked and you are working, it is this 0.375. But you see, getting the 0.375 is not a difficult part. The difficult part, 1, is identifying whether it's binomial or Poisson. 2, identifying the elements. The elements. That is key. That is key. That is key. That is key. Okay. And again, I'm expecting that you will learn the process. By the way, when you work it, you get this answer. You will understand the procedure done and get the answers. For me, that is key. All right, let's go to the next question. And each time check whether it is, by the way, the previous one, I could have asked you something. You see, the question was exactly 2. The question was exactly 2. And when we worked for exactly 2, do you remember the answer we gave? We wrote the probability as p into bracket x equal to 2. That's exactly 2. But what if he has said that no more than 2? No more than 2. Who can tell me what the symbol will be there? X what? To 2. No more than 2. Who can tell me what that will be? No more than 2. No more than 2. What will be the relationship between this x and then the 1, the 2? The no more than 2 would have been what? Because these are the questions you normally get. Nanabin, no more than 2.
So that'll be x equals less than or equal to 2.
X will be less than or equal to 2. That's it. Because the word no more than is greater. Okay, so no more than 2 will be probability of x less or equal to 2. How do you work that? Well, watch it. If you're going to ever work probability of x less or equal to 2, this is how you work it. This is equal to, you first find the probability of x equal to 0 plus find the probability of x equal to 1 plus find the probability of x equal to 2. And then you add them. So that means that you've got to go into this formula. Okay, you got to go into this formula and then solve for x being 0. And then you solve it. Then you go into the same formula, solve for x being 1. Then you go into the formula again and solve for x being 2. Using the same probability. The only thing that is changing here is x. Once you finish, you sum them. And that becomes your probability of x, finding x no more than 2. No more than 2. Now watch it. What if it has been the probability of what is the probability of finding a success which exceeds 2? Okay, the probability of success that exceeds 2. The probability of success that exceeds 2. How will you write it? X, what will be the relationship between x and the 2? The probability of success exceeding 2. And how would you work it? Okay, if it is a probability of success exceeds 2 is greater than 2. So the way you're going to work it is probability of x greater than 2. And how do you work that? Well, that means that you need to solve for the probability of x being equal to what? 3, because exceed 2 means 2 is not part. Okay, and note the number of trials here. What was the number of trials? In this case, it was 3. If it was 4, then you would have worked for the probability of x equals to 3, and then work for the probability of x equals to 4. Okay, but because the total is 3, you solve for every probability which is 3. But please let me give you a trick. The probability of x equal to 3 is also 1 minus the probability of x less or equal to 2. So if I get the value of 1, I can solve for the probability of x less or equal to 2, which unfortunately, or fortunately, depending on where you are, it is all of this. Once you've worked on all of this, it's 1 minus that answer, and that will give you the probability of x greater than 2, or that exceeds 2. So it's not all the time you're going to find exactly. Let's go on the next example. It will help you get a better understanding of what we are doing. Let's look at it. Samsung Gun gives a 2-year warranty on the phones it makes. This is tricky. Even finding whether it's binomial or Poisson. Samsung gives a 2-year warranty on the phones it makes. Now, from past experience, the company knows that 0.5% of the phones will be faulty and fail within the warranty period. 1, what is the probability that out of a consignment of 500 phones, none will be faulty? B, more than 3 will be faulty. Now, the first thing I want you to think about here, and raise your hand and tell me why, is this a binomial or a Poisson question? Is this a binomial or a Poisson? You can raise a hand and walk us through why it is a binomial or why it is a Poisson. Your capacity to do this is critical. Your capacity without copying from anywhere, by thinking in your own mind. Let me go back to the question. Okay, it's important. Let me give it to Eleanor. Eleanor, tell us.
Doc, please, I think it's binomial.
Why?
Because there are only two possible outcomes. The phone can either be faulty or not faulty.
Okay. Yeah. But if I tell you that is wrong, then the answer is going to be somebody is going to give me a different thing. Your explanation is wrong. Your explanation is wrong. You can give me another answer, but I'll come back to you. Let me go to Mark. Van Dyke.
Okay, sir. It is Poisson because we are going to assess the number of phones that are going to be faulty within the warranty period, which is 2 years. So it is
hold on. So what would have made her answer correct? You're right, but what would have made her answer correct? If what? Mark.
If we're not going to assess the number of phones that were going to be faulty within the time frame.
What time frame is that?
That 2-year warranty period.
Thank you. So guys, it's not a matter of a yes or no, accept or reject, defective or not defective. That is not the only thing you are watching, okay, for binomial. But if that yes or no is within a certain time or space or period, if it is within a certain limited situation, then it's no longer binomial. And that is a fantastic answer Van Dyke is trying to explain. That if what you are saying, the faulty, yes, we know that when something is faulty or not faulty, that's binomial. But this is within a certain period. So within that period, it gives you the fact that it being faulty or not, we are talking about average. Average. So you can even have yes or no. You can have male or female, but within a certain period. You can have a toss of a coin, okay? But if that toss of a coin is within, okay, if we have to play that toss of a coin within a certain time period or a certain geographical limitation, then it defeats the binomial principle of it. Now we move into the Poisson. That's the point made by Van Dyke. All right, so now that we know it's Poisson, in terms of Poisson, there are certain things we need to do. We first of all need to know the formula for Poisson. Okay, so we need to know the formula for Poisson. The formula for Poisson is you guys have written it, but let's identify the elements of the Poisson formula. Let me go to the board to showcase the elements. But please, guys, if we are doing this and you are not actually writing some of these formula, that is not good. Okay. So note that. So Poisson formula. Okay. The formula says probability of X is equal to, and then you have e to the power negative lambda. And again, lambda we know is the average. Then you have lambda to the power X, all over X factorial. This is the formula. So what do we need in Poisson? Well, if you can remember binomial, we need 4 items. In Poisson, what do we need? In Poisson, we need as well the sample size. Okay. If it is given, we need. If it is not, we leave. Okay. And then we need, as for E, we know the value of E is 2.178. Okay, we know E. And then we need our lambda. In fact, that is the main thing we need, lambda. And then we need our X, which is what we are normally going to calculate. And that X can be preceded by exactly X. You may have something like exactly X, that, okay, or more than X, or less than X, or no more than X, or at least X. You know, there will be some things related to that X. But the key is a lambda. That's the key, is a lambda. Now let's go back to the principle and try to see how are we going to be able to find this lambda. But there were certain things in the question, which is deep in this one. It says that within that 2 years, from past experience, it knows that 0.5%, see the thing? 0.5% of their phone will be faulty. 0.5% of the phones will be faulty. So how many are the phones then? So that we know how many will be faulty. How many are the phones? You can raise your hand and tell me. How many are the phones? So that we know how many will be faulty. Remember, the lambda has a name. The lambda is the average probability, okay? Is the average probability of success. So how many of the phones do we have to know how many will be faulty? How many of the phones? 500, fantastic, okay? Emmanuel says 500, and that is true. So if you look at the story, it says that of a consignment of 500 phones, so out of the consignment of 500 phones, okay, now we know that 0.5% of that will be faulty. And that is the mean. Oh, harataputoto. So watch the word. The mean, in this case, the mean wasn't given directly, but you should be able to find the mean within the warranty period. That is what we know is the mean, is within. And out of the 500 phones, we know that 0.5% will be faulty. Okay. That is the mean. He could have given us the mean straight away. And when you multiply 0.5, so that mean is a lambda. That mean is the lambda. So when you go, if you want to find the lambda, it is 0.5%, sorry, 0.05%. Sorry, 0.5% is 0.05. Yeah. Sorry, this thing, what was it? It's 0.05%, right? 0.5%. 0.5% is 0.05. Okay, so that will be 0.05 times the 500. And 0.05 times 500 will be 2.5. So that is a mean. That is a mean. Van Dijk, your hand is up.
I think 0.5% would be 0.005 and not 0.05.
Oh, thank you. Thank you. Very good. 0.005. Okay, fantastic. Okay, 0.005. Thank you. Thank you for that. So 0.005, yes, you see, I have that in mind and I'm now calculating this. So 0.005 times 500, you take a calculator, 0.005 times 500, that will give you 2.5, I thought, yes, 2.5. So you have 500 times 0.005, that will be 2.5. So the mean is 2.5. The mean is 2.5. Now that we know that the mean is 2.5, you have to substitute it into the formula, but you have to know which x you are finding. What is the x question? So go back to the story and find which x you are dealing with. It says here in the story, it says that out of that 500 consignment, where you have 0.5%, none will be faulty. None will be faulty. None will be faulty. So in this case, S equals what? In this case, X equals what? X equals what? None will be faulty. X is what? See the point? See the point? See the point? X will be equal to 0. X will be equal to 0. And so it means that in this context, for the first part, you are going to find the probability that X equals what? 0. So you're going to find P into bracket X equal to 0. Okay, that's what we are going to find. P into bracket X equals 0. So let's write our formula. We have equal to E raised to the power negative lambda. And what is the value of E? Okay, we know that. Okay. So when you take a calculator, you know the value of E. Negative lambda is negative 2.5. Okay. Then lambda to the power X, and that is 2.5 to the power X, and to the power X is to the power 0, because X is 0. all divided by x factorial, and x factorial is 0 factorial. That is how you work it. 0 factorial. Teresa, ask a question.
Sir, please, I want to be clear on something. The 0.005, you said percent. So if you are converting, it would be 5 divided by 100.
It is 0.05%. Watch it. The question says 0.05%. Is it?
Yes, sir.
Yeah.
Yes, sir. Thank you.
No, not 0.05%, 0.5%. It's 0.5%. And 0.5% is 0.5%, yeah. So just divide it by 100. You see it, 0.5%. So 0.5 divided by 100. And you see that you get 0.005. Okay, so it's not 0.05, it's 0.5%. Okay. It's 0.5. 0.5% is 0.5 over 100. 0.5% is 0.5 over 100. And 0.5 over 100 is 0.005. So that's what you multiply by the 500 to give you the 2.5. All right. So once you've done that, you substitute and then you find this calculation. 0 factorial is 1. So everything else is going to be the numerator. So this way your calculator. I don't know where your calculator is because I am. Some of you are using your mobile phones now, but remember in an exam situation, you're not going to use your mobile phone. You're going to use your calculator. So it's good to familiarize yourself with the calculator now. Okay. So you have to take your calculator now and then work within that parameter of the calculator. Now I can see my E on my calculator. So you write your E and then E is 2.718. Okay. E is 2.718. So you can substitute that into the formula. Okay. So you have 2.718 to the power negative 2.5 times 2.5 to the power 0. Any number raised to the power 0 is 1. So it's times 1 all over 1. Okay, because 0 factorial is 1. So this is actually going to be generally 2.718 to the power negative 2.5. So your calculator, you write 2.718, okay, and then 2.5, you type to the power negative 2.5. When you do that, the value you get, and again, you got to do this. You got to do this, not wait for me to do it with you. You got to do this, okay? Because if you don't do it, you'll be wrong and you wouldn't know that you are wrong, okay? But when I did it, when you do it, you will see that the value you're going to get, and what I'm getting here is 0.082. That's what I'm getting, 0.082. Now, if you don't get that 0.082, what it means is that you didn't put certain things in brackets. So if you type your E, okay, if you type your E to the power, you have to bring some brackets. And I see sometimes students do that. To the power something. And again, it depends on the kind of calculator that you are doing. Okay. E to the power, okay, negative 2.5. Okay. If you don't bring that to the power, that negative 2.5, you have got to bracket that. If you don't bracket that, you will not get the answer of 0. Let me show you my answer. Okay. You should get 0.082. Those of you who worked it, did you get that? Okay. Yeah. Okay. Levine and Miss Hateka, all of them are getting it because they are working by bracketing that negative value. You got to bracket it, else you'll get it wrong. That's why it's good to familiarize yourself. So this is going to be 8.2%. If you multiply by 100, it is 8.2%. So the chances of you getting a 0, no faulty phone, no faulty Samsung phone, the chances of you getting that is 8.2%. So you stand 8.2% chance of not getting that. Fantastic. Fantastic. So you have 8.2% of no failures in the world. So it means that there might be a modicum of failures in the world. Now let's go to the second part of the question. The second part of the question says, it says that, what is the probability that out of that 500, more than 3 are faulty? Watch the word, more than 3. More than 3, okay? We know we are working with the binomial. So more than 3 means probability that X is what? In relation to the 3, X is what? You can tell me. X is what? Okay. X is what in relation to the 3? More than 3 are 40. Okay. S is what in relation to the 3? Greater than. Fantastic. Mark. So that is greater than. Now, how many phones do we have? The sample size here was what? How many phones do we have? 500. And so when you are talking about more than 3, do you know what that means? It means that you are going to calculate the probability that X is more than 3, which is X is 4, X is 5, X is 6, X is 7, X is 200, X is 499. You have to do all of that calculation. You will be dead. Your grandfather will come and pick your bones. Okay, so there's a way to do it. Remembering that probability is always between 0 and what? And 1. Probability is always between 0 and 1. And so if I cannot go all the way to 500, I can do 1 minus that thing. So what do you think this can be? This means that you need to calculate 1 minus certain probabilities. What are they? You can tell me. You are taking the opposite of that. Because remember, this is greater than 3. Greater than 3. You can tell me that. You got to be incredibly smart to tell me that. Okay. Daniel.
Probability of X less than 3. 1 minus probability of X less than 3.
Again.
Probability of X more than 3 will be equal to 1 minus probability of X less than 3. Please suppose X is equal to.
Daniel, that is not correct. Hold on. That is not correct. And you'll come and see very soon why that is not correct. Okay. You said probability of 1 minus the probability of X less than 3. That is not correct. Let me go to Redeemer. Redeemer, tell us. What would that be?
A probability of X less than or equal to 3.
Again.
Probability of X less than or equal to 3.
That is the correct thing. Because if the first one is telling you greater than 3, it means 3 is not part. So its opposite will be less or equal to 3. So we are looking at probability of, okay, X less or equal to 3. Less or equal to 3. Because the first one was greater than. So its opposite will be less or equal to 3. Now, that means that you're going to find 1 minus probability of what? You can tell me. 1 minus probability of what? Agnes has already done that there. Okay. Agnes, the only thing you should do, okay, she's done it correctly even. Okay. Because you have to let the brackets affect all of them. So you should have probability of X equal to 0, okay, plus probability of X equal to 1, because remember they are all less than 3, less or equal to 3, plus the probability of X equal to 2, and 3 itself is part of it, plus probability of X equal to 3. After that, then you close it with a square bracket. So this is how you got to compute your probabilities. And if somebody is not listening, somebody is listening. Agnes, your mistake is that you omitted the 3. You omitted it. The 3 is part of it. The 3 is part of it. Okay. More than 3, its opposite is less or equal to 3. More than 3, its opposite is less or equal to 3. So in an exam, if the person doesn't include a 3, the person spoils everything. You get it? So that means you need to go and calculate this probability, calculate this probability, calculate this probability, calculate this probability, and then bring all of them, subtract all of them from 1, and that will give you your final answer. Now let's see how we did it here. Okay, so this is how we did it here. So you got to calculate for each one of these. Each one of these. You can see. Watch it. The probability of more than 3. The probability of more than 3 here. That. Okay. This probability of more than 3 that you are seeing here. That is 1 minus the probability of x being 0 minus the probability of x being 1, x being 2, and then x. And when you calculate for each one of them like that, when you calculate for each one of them like that, when you calculate for each one of them like, again, respecting your calculator, then you subtract all of them from 1. And that will be, so it means that the probability of getting more than 340 is 24%. There are 24% chances of getting more than 3 phones expiring. Okay, that is what it means. Okay. All right. Any question on this before we go to the next one? The next one, I'm not going to calculate the story with you. I'm going to just show you how you should identify whether it's binomial or Poisson. That's all. Okay. I'm going to show you how you should know whether it's binomial or Poisson. And once you're able to identify whether it's binomial or Poisson, at this stage, I'm expecting you to be able to calculate all of it. Oh, okay. So let me show you the question. This is the next question. First, all we have to do is to know how to calculate binomial or Poisson, and then there are a little bit of the tricks attached to the X. Suppose that the number of customers arriving every hour at the only checkout counter in a local pharmacy is approximately distributed with an expected arrival rate of 20 customers per hour. Is this binomial or Poisson? That's all I need to know. Is this binomial or Poisson? Because if you can tell me whether or not it's binomial or Poisson, that is the most important thing. If you can redeem yourself with that, you're done. Michael, is this binomial or Poisson?
It's Poisson.
How? Why?
Okay, so each hour means it doesn't happen once. Meaning it's and we don't have the exact what do you call it? The exact what he's talking about. So, and also suppose the number of customers arriving each hour. So every hour.
That's the most important thing. That's what you should have spoken about first. Okay. So the customers are not just arriving, but they are arriving at a limited time period. I told you guys, please note, limited time, limited space, limited page, limited square feet, limited mile, limited something. Okay. In this case, there's a limited time period, and that is what shows that it's Poisson. Once you now know it's Poisson, the rest is history. Calculate it. Now, remember, the sample size here, the mean is 20. So the lambda here, since it's Poisson, the lambda, since it's a Poisson, the lambda here was given as 20. So this one, it was given straight away, unlike the previous one where you have to calculate it. Now, what does exactly 10 here mean? How will you calculate that? Find the probability of exactly 10. So we'll have P into bracket X what related to 10. How would that be? Exactly 10. X what related to 10? X what related to 10? What symbol is that? Equal to, thank you. That's the answer. Now, let's go to the next one. At least 5. At least 5. At least 5. Probability X what related to 5? X what related to 5? S what related to 5? Eleanor. S what related to 5? S what related to 5?
Greater than or equal to.
Again.
X is greater than or equal to 5.
Okay, Elena, how will you work that? X is greater than or equal to 5. Remember, this thing goes all the way to 20. So how will you work that? How would you have solved that?
Okay, Doc, I'm lost there.
All right, okay. Who can tell me how would you have worked that? I just want an explanation how you would have worked that. Let me go to Nana Benny. How would you have worked that?
So you'd have found the opposite, which should be 1 minus P, X less than 5.
Again, X less than 5. Okay.
X less than 5.
And how would you have worked that?
So that would be P into bracket X is equal to 0 plus P into bracket X is equal to 1 plus P into bracket X is equal to 2 plus P into bracket X is equal to 3 plus P into bracket X is equal to 4. And then you close your bracket and then you to find that total and subtract from 1.
Perfect. I like that conclusion. Closed, find, and subtract from 1. That is a key. That is a key. That is a principle. Once you get a principle, I guarantee you are ready to rock and roll. Okay, that is how you do it. That is how you do it. I'm jumping that, going to the next question. Okay, so the next question. In a typical month, an insurance agent presents life insurance plans to 40 customers. This is tricky. An insurance agent presents life insurance to 40 customers. Historically, that is previously, 1 in 4 customers chooses to buy life insurance from the agent. Historically, 1 in 4 customers chooses to buy life insurance from the agent. Based on this relevant information, answer it. Is this binomial or Poisson? Is this binomial or Poisson? Of course, I'm going to ask you why, how. Is this binomial or Poisson? That's all I need. Is this binomial or Poisson? Because imagine if this was an exam and you are battling as whether it's binomial or it's Poisson, it's binomial or Poisson. That is a tough area. Is this binomial or Poisson? Who is ready to showcase that? Okay, I've got some answers. Okay, so let me go to Agnes. Agnes, is this binomial or it is Poisson? Yes, Agnes, unmute yourself.
Please, I think it's okay. The typical month. Okay, it's Poisson because of it says in a typical month, so it's given as a duration, a time frame, which is the month.
Okay. Those of you who agree with her, lower your hands. Those of you who agree with her, lower your hands. Agnes, you yourself have not even lowered your hands. It means you don't agree with yourself. You don't agree with yourself. You said something and you don't agree with yourself. Okay, let me go to Eleanor. Eleanor, you say you don't agree with her. Tell us why you don't agree with her.
Look, my hand was already raised. I didn't let it down, but let me try.
I didn't say she's wrong or right. I'm only
yes. So I'm going to, I don't agree. I actually thought it would be binomial. Okay. I don't think the typical month is really telling us anything that we are is specifying that in a month that is what is expected to happen. It is just giving an example that in a typical month that's what happens.
So what makes you think is what?
So I think it's binomial because for them, it is either you buy the insurance or you don't, whether it's in a month, in 2 months, in 3 months.
Yeah, that's it. That's it. Well done. Well done for defending it. So the typical month doesn't mean anything because first of all, you don't know how many days are in the month. So we can't use, it could be 28 days, it could be 30 days, 31 days. Okay. And the key point is a choice, is binomial. There are two options. 1 in 4 customer chooses to buy, you either choose to buy. But if you have said they choose to buy in a particular year, or in 2 years, on 3 years, on 5 years, then you are now seeing the limitations. Then you are talking about Poisson. But they choose to buy life insurance from the agent, which means they can choose not to buy the life insurance from the agent. And so that shows it's binomial. Okay, so if it is binomial, the next thing becomes, what then is a probability? If it is binomial, as you all know, in binomial, you have to find the p, and then you have to find the 1 minus the p. Okay. So what is the p? What would be the p? What would be the 1 minus the p? And what would be the n? What is the p? What is the probability here? It's there. It's there. It's there. What is the probability? Eleanor, do you get it now?
Yes, Doc, I'm still trying to figure it out.
Okay, Michael, let me go to Michael. Michael, tell us, what is the p? What is it? What is a p? What is the probability? Oh, Michael has vanished. Okay. Redeemer, Deborah, all of them says the p is 1 over 4, which is correct. Nana Poku, the same thing. So 1 over 4, because it says 1 out of 4. 1 out of 4 customers choose to buy. 1 out of 4 customers choose to buy. So it just shows that the probability of success is p, which means that if probability of success is 1 over 4, then the probability of failure will be 3 over 4. Okay. What is the sample size here? What is the sample size now? N. What is our sample size? I'm sure you all know that's 40. Now let's go to the question. Exactly 5. Exactly 5. What is the relationship between the x and the 5? Exactly 5. Exactly 5. What is the relationship between x and the 5? Type it there for me. Between x and the 5. Perfect answer. Equal to. Good answer. Good answer. So that is it. Okay. That is exactly 5. Now, what if you have this question? Still on that. Still on that. You said, what is the probability that no more than 10 customers? No more than 10 customers. What is that? How will you write that? No more than 10 customers. Van Dijk.
I'm not answering this question, but I'm rather answering. I have a concern about this situation being binomial or Poisson.
Mm-hmm.
I think if you're not going to use the figure 40, if you're not going to use it in the calculation, in our calculation, then it will make it binomial. But the moment we decide to use the 40, that 40 will not occur within, it will occur within a month. The month, irrespective of which month, whether February or January or whatever, we may not even know the number of days in a month, but it is occurring within that period of a month. So the moment we decide to use 40, it will make this scenario a Poisson scenario, not binomial.
So if you were not using the 40, you said
yes,
it was binomial.
Yes, please.
Okay. If you were not using the 40, what would have been your sample size then? What would have been your sample size if you were not using?
Can you go back to the question? Can you go back to the question?
All right. Okay. So this is the question. Tell me what would have been the sample size.
I think it will make the question illegitimate. But
it's not illegitimate. It's because of the way. That's why I asked you that question. It wouldn't make it illegitimate, Van Dijk. The thing is this: when your mind is too much on the typical month, you will lose the point. That's the first thing. Second, okay, remember the element. As for the probability, we are not arguing with it. 1 in 4 customers. Now that word, 1 out of 4. Okay, that statement 1 out of 4. That's not what binomial gives. Sorry, that's not what Poisson gives. Poisson does not give you probabilities. Poisson gives you means, the average over the period, okay? And when you look at this, I asked you that question because I wanted you to tell me what would have been the sample size. So if the question is as you said it and he said it's Poisson, if it is Poisson, what would have been the lambda? What would have been the lambda here? How would you have calculated the lambda? How would you, because there was no particular time limitation, space limitation given. The only thing that could confuse somebody was the typical amount for the person to think that it is Poisson. That is what the lady said. That is the only thing. If you take that one out, because again, that typical amount, we don't know what typical amount it is. If we are talking about year, you have to tell me the typical year. So in one, we said 2-year warranty. If we are talking about a week, okay, if you are talking about week, you got to tell me one particular week, whether it's 2 weeks, 3 weeks, 5 weeks. If it is a month, you have to tell me, you know, a particular month. In the month of this, okay, so that you know what you are dealing with. So that generalization of a typical month, it does not make it a Poisson. It doesn't make it an average.
Okay.
So that is why it is a binomial and not a Poisson.
Okay, sir. Thank you.
All right, so let's go back to this part. Okay, what is the probability that no more than 10 customers? I'll quickly go through this because of the time. No more than 10 means probability of X, okay, less or equal to 10. I'm sure you will all know this. That's no more than 10. That's no more than 10. That means 10 or less. No more than 10 means 10 or less. Now remember the 10 is inclusive. So that means that, and this is 20. So it means that you have to do 1 minus the probability of 0, 1, 2, 3, all the way up to 10. Oh, sorry. You have to do probability of 0. You have to just do the probability of X equal to 0 all the way to 10. That's it. And then you sum them to find this. That is what it means. Okay. Then you have, what is the probability that at least 20? At least 20. Oh, this was 40, by the way. The sample size was 40. So at least 20. Oh, hold on. Let me go back to the one I did so that I don't get confused. So the one I did, okay, no more than 10. Okay, no more than 10 is 10 or less. 10 or less. So that means you need to calculate the probability of 0, 1, 2, 3, up to 10. That's it. Nothing else. You don't subtract anything. But when it comes to this, at least 20 means probability of X greater or equal to 20. And since the 10 is 40, you have to do 20, 21, all the way up to 40. That is simple. This one, whether you do 1 minus, is around the same movement, the same calculation. So because 1 minus will be 1 minus the probability of 0 up to 19. So you still have to go a long way. Okay. And then the last part. Yes, Nana Benny, you have a question. Nana Benny, you have a question. Go ahead.
Yes, sir. So I wanted to ask, so given an exam situation where you have the question 2 being at least 20 customers, and then you've already solved for the no more than 10. Mm-hmm. So ideally, if you can you make a reference to?
Oh yes, you can always do.
And then continue from 11 to 20.
Exactly. Continue from the
11 to 19, and then you subtract from minus 1. From 1, sorry.
No, you do from 11 to 19.
Yes.
Add that 11 to 19 to the first one you did. Then you subtract all from 1. Yes.
Yes.
Perfect. You can do that.
Okay. Thank you.
And the last one is the probability, finding the mean and then the standard deviation. Now remember, finding the mean, I told you about it, and I'll come back to it. The mean was this. Okay, if you can remember, you take the X and then you multiply it by the probability of the X. Okay. So you take the X, you multiply it by the probability of X. You take the very number, and then he says, who will buy life insurance from the observation in the coming month? So how will you calculate it? We have that formula, that long formula I gave you. So you find the mean, and then you find the standard. Before I go and show you how to do that, all you got to do with the standard deviation is to finding the square root of the variance. Remember, the variance is sigma squared. So you find the square root of that, and that gives you the standard deviation. You find the square root, and then that will give you the standard deviation. So in conclusion, let me show you how you will work out that one. So finding the mean, the sample size times the probability. The sample size is 40. Okay, the probability that was given was 1/4, which is 0.25, and that gives you the mean. The standard deviation is that sample size, okay, multiplied by the probability of success times the probability of failure. The probability of success was 25%. The probability of failure is 75%, times the sample size of 40. You take the square root of that. Remember, the square root here taken is because you are dealing with the standard deviation. If not, we would have just left it there if we were dealing with the variance. And when you do that, the standard deviation is there. So in this case, he's just asking you to find the mean and the standard deviation. The mean is the sample size times the probability. Like what I just showed you, I told you is the X times the sample size times the probability. And then this one. Once you're able to do this, you are good to fly. You are good to fly. There are several other examples that are here that I will encourage you to go and look at. Okay? Because when you look at them, you will see that it is cool. The most important thing is identifying whether it is binomial or this Poisson. That's the first thing. Once you have gotten the formula, then the tricks start coming around the X. Okay? Whether it is more than, is less than, is at least, and all of that. Next time, what I'm going to do now is to show you the last distribution, which is the easiest one, actually, the normal distribution. The normal distribution. Ladies and gentlemen, wow, welcome to the valley of the shadows of management science.